This problem says a parallel plate capacitor has circular plates, each with a diameter of 20 millimeters. The plates are separated by a 0.20 millimeter gap that is filled with a material that has a dielectric constant of 8. What is the capacitance of the capacitor? So let's list our givens. We have a circular plate, so we know that the area formula may be involved. We may need to have that, so we'll have that handy. We'll do pi, area equals pi r squared. Then we have a diameter of 20 millimeters. We'll convert that to meters because it's always helpful. So 20 millimeters, there's 1,000 millimeters in 1 meter, so we get 0.02 meters. Next, we see that we have a 0.2 millimeter gap, so we'll convert that also to meters. 0.2 millimeters, we'll do the same, divided by 1,000. 1,000 millimeters is equal to 1 meter, and we get 0.000. Is there one more zero? Let's check. 1, 2, 3. Just 3 zeros. Then we also have a dielectric constant of 8. So we can say that K is equal to 8. Now we can look at our equation table. What equation table will help us find the capacitance, C, and has all these variables that are included? I'm looking and I see that C is equal to K times epsilon naught times area divided by distance. So this looks like a good formula because it has the area, which we have here, the 0.02 meters, which will be included in the area, and then the distance of 0.02, which will be included right there. And then the K of 8.0. And then epsilon naught, that is a constant, and that is equal to, epsilon naught is a vacuum permittivity. We can look at the back of our equation sheet, and it has a value of 8.85 times 10 to the negative 12 coulombs squared per Newton meters squared. We can start plugging in our values. Capacitance is equal to K. We have a K value of 8.0. Then we plug in our epsilon naught value, 8.85 times 10 to the negative 12th. And then our area value is pi r squared. And our diameter, this is the diameter, 0.02. To get the radius, we just do diameter divided by 2. 0.02 divided by 2 is 0.01. So we can plug that in as the area, and we'll get pi times 0.01 squared all over the distance. The distance is equal to this value right here. So we can plug 0.0002 into this. And then if we plug this into our calculator, we get approximately, let's calculate this, we get a value of about 1.112128 e to the negative 10. So this is approximately equal to 1.1 times 10 to the negative 10. And this is closest to our value of B, 1.1 times 10 to the negative 10 farads. So B is the correct answer.